Hey folks, welcome back to the next episode on Clear My Paper. In this episode, we are going to talk about solving a problem, and the problem is going to be finding the adjoint of a matrix. In the last few episodes, we did understand what is the adjoint, and like I said, adjoint and inverse of a matrix are pretty much the most culminating topics which kind of completes the syllabus of a matrix. So let's discuss or take a sample problem and solve or find the adjoint of a given matrix. Or let's apply what we have learned so far. So the problem that is given is we have a given matrix A, which is a 3 by 3 matrix, and we have been asked to find the adjoint of this matrix. And like I said, before you solve any problem in mathematics or any other subject, just take a one or a few seconds time off in your head, close your eyes and think about what is being given, what is being asked, and what is that what are the different ingredients that you need to bring in to solve this problem. So we know that they have given us a 3 by 3 matrix. We know that they are asking us to find the adjoint of the matrix. And now we need to know, okay, for adjoint, what are the different ingredients that I need to recall from my muscle memory? Okay, what is the mental work I need to do? I know that adjoint of a matrix is nothing but a transpose of cofactors matrix or a matrix of cofactors. Okay, that in turn means, what is a cofactor matrix? A cofactor matrix itself is a matrix of minors with a alternating plus or minus sign. That's interesting. And what is a minor matrix? A minor matrix is a submatrix of a lower order. Since the given is 3 by 3, we are going to form a 2 by 2 submatrix, and that matrix is going to exclude the element, the row and the column of the element for which we are finding the minor. So we need to just quickly recall this, and although it's a top down, from adjoint we are going to cofactor, from cofactor we are going to go to minor. While you actually solve, we are going to go in the reverse order. You're going to find the minor first and then the cofactor, and the last step would be finding the adjoint. So that's the interesting part. So you, in terms of interpretation of what you need to do, you go kind of this way, but in terms of solving, you're going to go in the opposite way. Okay, and the interesting thing about this problem is, although they're easier to solve, there is no way to verify if the answer is correct or not. No easy way where you can put back the values, because at the end of the day you're going to get a matrix, and there is no easy way to find out whether the matrix is right or not. So hence you're prone to some mistakes along the way. So just be careful. That's the beauty of all of the matrices, right? Most of the problems are easier to solve but difficult to verify in some instances. So you need to be careful to avoid any simple calculation mistakes. So let's jump into the solution of this problem. I'm rewriting the problem as it is, the matrix. And what I know is, like I said, I'm going to find the minor first, and then the cofactor, and then the adjoint. So let's dig into the minor part of that. So I know my matrix is a 3 by 3 matrix, and hence it's going to have 9 elements. And for each element, I need to find minor. That means I'm going to find 9 minors. And what I'm going to do is, I'm going to go slow, take one row at a time. On each, we are going to find the element of minor of element, every element in each row. We'll go row by row. Okay. And just a word of caution, since we are doing this in the context of determinants and matrices and going back and forth, there is some mistake that I generally do, and I hope you guys are much smarter than that. We have to find the adjoint. We don't have to find the determinant. Okay, although we need the minor, we have this habit of multiplying the determinant. To find the determinant, we find the submatrix and multiply by the coefficient. We don't have to do that multiplication part. There's nothing here to multiply outside this matrix. There is no scalar effect, there is no multiplication. So do not do this. I normally kind of do that mistake, and then I realize it much later in the problem solving. So do not do this. Very, very important. Okay, don't find the determinant. We just need to find the minor, okay, which is a submatrix. And like we discussed, we're going to take one row and each element in a row. So I formed this nine matrices, and it's always a good habit to rewrite this matrix and knock off or cross out the row and column which you don't need, for which you're going to find the minor, and which is what I've done. So I've repeated it 9 times. I'll show it once and then you can understand. So I'm taking this whole calculation is for the first row, this part. Okay, this part is for the first row. And the first row has got 3 elements. We have 2, then we have 5, and then we have 3. And for each one of them, I'm crossing it out. I'm circling the number for which I'm finding the minor. I'm going to find the minor of element 2. Element 2 is in first row and first column. I'm cancelling it out. And whatever is remaining, I'm going to find the determinant of that submatrix which I've rewritten here. I'm exactly writing it as it is, whatever is remaining, 1, 2, and 2, 1. and I'm going to find just the determinant. I'm not going to multiply this by 2 to find the determinant. That's just something that we should not do. Focus on that, okay? So just find the determinant, which is nothing but cross multiplication of the diagonal elements. You start with this diagonal, and then you take this diagonal, and then you take the difference of them. And the same way, the minor of 5, I'm going to cross out the row that is highlighted. It is in first row and it's in second column. I'm going to cross out that, and whatever is remaining, I'm going to take that as a sub matrix over here and find the determinant, and so on and so forth. Like that, I've done it for row 2. This complete thing is this whole thing is row 2 from here to here, and then I've done it for row 3. So rewrite this matrix. It helps you avoiding calculation mistake. So after you do that, you will have, for all the 9 elements of the given matrix, you have steadily found out the 9 respective minors for that element, which is highlighted and encircled in orange color. So there are 9 elements, and I'm going to form a matrix of all these 9 newly found orange colored minors in this fashion. So now the first step is clear. We have created the matrix of the minors. So we have got that, something in orange color. The second step, like I said, while solving, we are going backwards. We have found the minor. This is done. I'm going to find the cofactor and then the adjoint. And a cofactor, I know, is nothing but taking the matrix of minus and padding it up with alternating plus or minus sign. So let's do that. So I've copied the cofactor cheat sheet here, which is nothing but all the diagonal elements should be positive and all the non-diagonal elements is going to be negative. So whatever is on the diagonal, you leave it as it is. You don't have to change whether it's positive or negative, because that's not going to impact. But whatever is on the non-diagonal, which is what I have highlighted in purple color, the 4 elements, whatever is in the 4 elements, the non-diagonal, that I need to negate. I need to do the opposite of what's going on, okay? So let's do that over here. If you see here, I am writing all the matrix again, and whatever is in purple color, these 4 elements, this one, this one, this one, and this one, I've underlined here, okay? And I've written the matrix, and I'm negating the sign. That's it, because I need to apply a negative sign to that, okay? And remaining elements, since they are positive, I'm leaving them untouched. And once I do the net of the plus and minus, I get a clean copy of this cofactor matrix, where all the negative elements have done their magic, and I get a clean matrix of this in this way. So that's the cofactors matrix, and that's the second step. And the last and the easy step is, I know adjoint of a matrix is nothing but a transpose of a cofactors of matrix. That is a transpose of this that I need to do, and a transpose is nothing but changing the row to column and vice versa. In other words, it's a reflection along the diagonal elements. The diagonal, which is in the format of backslash, that's going to remain as it is, and all the elements will get reflected along this diagonal. It's the same thing of row and column interchange, whatever works for you. So the first row over here will become the first column. So if the first row is -3, -1, and 5, that will become the first column. So it's -3, -1, and 5, and so on and so forth. So when I flip it and I interchange and swap the elements on the row and column, whatever is the final thing that I get, that is nothing but the adjoint of the given matrix, and that's the final answer. So this is what pretty much adjoint of a matrix is. And like I said, I really can't, there is no easy way for me to verify it, whether it's true or right or wrong. I mean, a quick way. I can verify it in a long way, but we don't have time in exam. So be careful and don't do the mistakes. One of the biggest trap is you will get into the habit of finding the determinant. So do not do that. Just find the sub matrix, the minor. Do not multiply it with the element that you're getting rid of. Okay, do not do that. So that's it pretty much on this. Finding the adjoint of a matrix, pretty easy, and that's how we have applied the principles that we have learned, and this gives kind of an example on how this works. So that's a quick wrap up on this video. I'll see you in the next new episode. Till then, stay tuned guys. Signing off on Clear My Paper.